Hello everyone, so welcome back to Dilip IT Academy and my name is Dilip Singh. In today's session, we are going to explore more about Spring Boot discovery clients along with integration of Spring Cloud API Gateway. So in our previous microservices sessions, we completed what is API Gateway and what is Service Registry, and continuation to that, we are going to discuss in this session. Yes, as part of this session, we are going to explore how to set up routing dynamically as well as how we are enabling services to register themselves automatically with our service registry application, and as well as we are going to see how we are avoiding the manual configuration as part of API gateway application so that we are enabling the dynamic routing across all microservices instances. Along with that, we are going to see how Spring Cloud default load balancing is happening. That means how efficiently it is distributing the traffic across all our microservices instances. So by end of this session, you are going to get completely hands-on experience for creating the service discovery clients as well as integration with API gateway along with service registry application, how internally the gateway is operating with service registry to find out multiple instances of an microservices and how it is choosing which instance has to be utilized for request execution or nothing but dynamic routing point of view, and how internally it is achieving load balancing. We are going to see every detail in this session. So right now let's get started into the session. So right now we are discussing about service discovery. So what is the difference between registry versus discovery? Also we discussed in our previous session. So registry is all about a separate application which collects all microservices information. So that means generally we created the registry application for the purpose of what? For fetching all microservices information. So that is the agenda of registry, service registry application. That's what we saw in our previous session. And when it comes to the discovery, what is the point of discovery here it is? Service registry application is going to fetch all microservices information, right? Whenever we started our microservice, so we understood like service registry application is going to fetch the information of each microservice. But it's not like by default, every microservice information is automatically going to be fetched by the service registry application. No, it's not by default or automatically. So for that, what we have to do here it is, we have to make, okay, so our microservices are enabled and as well as configured with service discovery functionality. So what is the meaning of enabling or configuring is nothing but. So that means now in this case, we are going to call our microservices once we enable service discovery functionality. So we are going to call it as discoverable clients, service discovery clients. Until and unless we are not enabling the discovery client functionality on microservices, that microservice is not ready to share information with the service registry. So that means to make a microservice as a service discovery client, first thing is what we are going to do here it is, we have to add a starter dependency. We have to add a starter dependency called as Eureka client. So when it comes to the service registry application, what we did guys, we created Eureka server application, right? We created Eureka server application based on our microservice point of view. This is all our microservices architecture we are following, right? So what we did, we created a service registry application as well as we created a API gateway. Now, in this case, when it comes to the service discovery point of view or discovery clients point of view, we are going to make our Spring Boot, okay, nothing but our microservices applications as a Eureka client application. So that means the overall microservices, whatever we are having, we have to enable each and every microservice as a discovery client or Eureka client. So that means then only what will happen. So in our backend application point of view, whenever we have gateway and we understood service registry application, right? So this is a service registry application. So it's an individual application. This application functionality itself fetching all microservices. So fetching all Eureka client applications, especially I can say like Eureka clients. So whatever the microservices are enabled with Eureka clients functionalities, so those microservices informations are going to be collected by this application. right? For that, what we have to do, we have to make sure all our microservices are enabled and as well as configured with discovery client functionality. So that means if you take an user and as well as order and as well as payment point of view. So these are all microservices point of view we have to enable with a functionality called as Eureka client. So similarly, we have to make everything for all microservices. So like this, we have to enable all our microservices with Eureka client functionalities, as well as what we have to do is we have to configure one more thing is, so we have to provide service registry URL in every microservice level. So that means two things we have to do here it is. One is the dependency we have to add Eureka client dependency so that all our microservices will become as a Eureka clients, nothing but which are ready to share their information. Now, as well as we have to provide service registry URL also in every microservice level. So why we have to provide? Yes, maybe tomorrow we may have a lot of other applications running in the same, right, same host or whatever it is. So we have to provide service registry URL also in every microservice level. So once we are done these two things at every microservice level, like for example, if you have 40 microservices point of view, we have to do same activity for all microservices we have to do. Then only all these microservices information will be shared here with respect to port numbers, host names, okay, context paths, all these host names, etc., health status, all these information of every microservices managed by the service registry application. So let's start making our microservices as a discoverable clients or Eureka clients. So step number one, what we have to do, add a dependency in every microservice. So what dependency I said, Eureka client. So we service registry is nothing but Eureka server, right? So similarly, when in the opposite point of view, we have to take in this case, Eureka client is the dependency we have to add here it is. So this functionality is also implemented by Netflix company only. So let's go here, what we can do. So let's go to our microservices one by one now. So yes, I have user microservice and let's go to the pom.xml file. So here you can do two ways. One is once whenever you are working with your STS, you can add from here Spring add status, or else you can just identify respective dependency starter from the online and you can add manually in the pom.xml file also. So let me show you what you have to do from this is existing add status I taken, right? So if you taken here Spring Cloud Discovery and here Eureka Discovery Client dependency or starter we have to select here. And then what it is saying is it is adding a new, if you observe here, Cloud Starter Netflix Eureka Client. So just select the pom.xml here. Okay. And then just click on finish it. Now go here, go to pom.xml file of user microservice, observe client dependency added or not, right? So it's added. You have to add, this is what in our every microservice point of view. And whenever it is first time you're adding, so we will have one version called as Spring Cloud version. So this is also most important. So you have to add this in the properties level. So please check this is being added in the properties level or not. So just properties level. That means simple guys, just which Spring Cloud version we are using as part of the starter dependency we have to define here it is. So Spring Cloud versions are different from the Spring Boot versions. That's why we have to add this one. So whenever you made that change directly from here, add status and all, so your editor is going to add that. But when you are doing manually, nothing but manually in the sense, tomorrow when you are adding same dependency, like by copy pasting from the internet. So if you are adding only this thing, maybe you will get some issue. For example, see here. So if I remove this, then the dependency is may have some issue with respect to version point of view. So that's why you have to add version here. So especially version you have to add here. So instead of you are adding as per Maven point of view, we have centralized properties point of view, then same property being added in this properties level. So then automatically it is taking 2024 0.00 version for this Spring Cloud version part. So this is one thing, please make sure. So that's why I just given here it is. So in the properties level, you have to add below one. So both are in add in pom.xml. So these are the two things you have to do that. So one thing is version. Assume already version is presented. Some reason you added some other Spring Cloud libraries. By the time version is already there, then you can add this one directly. So one time this should be presented. That is what. Okay. So with this, our microservices are going to be working as discovery clients means no. So second step is we have few more steps. We have to add another and one more annotation at our microservices main application class level. So what we have to do, like we did same thing in the service registry application also, right? When we created service registry application in the main method class level, we added an annotation called as enable Eureka server. Yeah, however, we added earlier in our Spring Boot service registry application level, we added an annotation called as Eureka server, right? Similar to this, we have one more annotation here. It is called as @enable discovery client. So what is that annotation is @enable discovery client. So please remember this annotation names. So we have to add this annotation at each and every microservice level. Add one more annotation at our microservice main application class level, and it is called as enable discovery client. So enable discovery client. So this is how your microservices should be configured now. So once you have done this, so our microservice is eligible as a discovery client means yes. So then what you have to do is, yes, now microservice is ready to share information with service registry application. But which service registry application? That's why what we have to do is add service registry URL in every microservice level. So that means with this, what we are trying to say to the our microservices Spring Boot applications point of view, we are giving the URL and we are saying like, hey, please go and register with this respective service registry application. Like that, we have to provide the address. Address means simply nothing but the URL. So once we given the URL, what these things, what Eureka clients or this discovery clients will do, this will share this all these informations with service registry applications. So that means, so now our microservices will start processing of start registration process. So let's do one thing before adding the annotation, before adding the service registry URL. Let's see here and let's start our applications. What's happening? Try to understand. See, first I am starting service registry application, and then I'm starting user microservice also. So let's see, by default, automatically this user microservice information is registered with service registry application or not. So let's open our Eureka server. What you have to do, localhost. What is the post number we given? 8761, right? And then we given URL also as a service registry, right? /registry. If you see here, still no instances. So why? Because we just enabled discovery client functionality on user microservice. But at the same time, we are not provided with which service registry application these microservices has to be registered. So that's why the third step is what you have to do is go to the properties file of microservice, user microservice. Okay, in the Spring application user microservice level, what you have to do, you have to add service registry URL. So let's see what is the property we have to add here. It is so something will be started with Eureka. See, these are all properties and that annotation enable discovery client. These are all things you can see only once you added that starter, guys. And that starter is nothing but Maven dependencies. Once all the jar files are got imported into your project, then only we'll see all these options. If you are not able to see these things, means your starter is not okay imported or downloaded the respective jar files properly. So please verify that. So now if you see here, Eureka, let's find out some URL. Eureka client service URL. Here we have something like default zone. So we have to give this property called as the default zone. And then URL. What is the URL, guys? So you just give this URL. And as well as, yeah, let's see this until this and let's try now. See, all our microservices instances will be restarted once again. Why? Because we added dev tools, right? So in case if you feel, you can restart everything one more time. See, now what we did, we added this URL in our user microservice level. And now we are observing user microservice getting registered with Eureka servers or not. See, it is still no instances. All our microservices got started, but still it is not registered here. The reason is something we have to add a URL called as something like Eureka here. Just end with Eureka. So we have to add an extension, okay, path called as /Eureka in this case. This is one point we have to remember. Let me restart our microservice user one more time. Okay, see all our microservices, I mean user microservice got started. If you observe here right now you can see your user microservice, the name what we given, that's what I said right earlier. This property is more important going on. So this property name only, all our microservices got registered with your Eureka server now. So see here now what it is saying, instances currently registered with Eureka. Which instances, which microservice? User microservice. How many instances? Three microservices, three instances, sorry, three instances. And what are the port numbers? 8010, 8011, 8001, right? So this generally in your systems, maybe you can see some host name or local host, something like that, guys. So I have some other configuration in my system. That's why you can see host.docker. But generally in your systems, you may see something like IP address or maybe local host, something like that. So don't worry too much about it. Okay. So now see here, what you have to understand, guys, user microservice. Under user microservices, how many instances? 1, 2, 3. Now let's stop one of the instance, whatever you want. So for example, I'm stopping one of the instances. So that means total 2 instance of user microservices I have right now. So now see here, come back to the Eureka service registry once again. So how many instances available again this time? 2 are available. So that means what's happening in this case, your Eureka server application or service registry application, it is keep on making a health check call to our microservices instances. So that means in the backend, if you observe logs, service registry logs. So see here, it will keep on checks health status of every microservice. See, it is checking, is it running or not? Is it running or not? See status down, 8011 status is down. So that's why what it is doing, it is removed that all information. See, when you started, 8000 status is up, 8011 status is up, 8010, that to which microservice, guys? User microservice. So and whenever you stopped one of the instance, automatically that 8011 is got removed from the registry. So that means now total 2 instances available. So this is how the dynamic instances, whenever we make the scale up of applications, so this dynamic scale up, whenever we perform, like increasing the instances and decreasing the instances, all that information is always in a up to dated format. Everything is captured by the Eureka server as a centralized point of view. So now same steps, whatever we did right now, we have to repeat for all microservices. So this is the URL you have to add here. It is. So total how many steps you have to perform on existing microservices when you want to make your application as a Eureka client application or service discoverable, means you have to do total 3 steps. Okay. So what are those three steps is? First thing is add the dependency. Eureka client dependency. So this is the main starter dependency you have to add. After that, you have to add this annotation. So you have to add this annotation in the main class level. And then as well as what you have to do, we have to provide the main service registry URL here, but to make sure when you provide it in the microservice configuration level, please make sure it is ended with /Eureka. So this is generally what you are using with respect to accessing from the UI perspective, right? So after that, just add Eureka when you added same thing in the microservice level. But when you're accessing from the just like user, from this UI portal point of view, you don't need to add it. Because the context path is up to /registry only. But when you are configuring in the microservice level, so please make sure ending with /Eureka. Now same 3 steps you have to repeat for every microservice. So let's do order microservice got started. Is it going to be registered automatically? Means no. Why? The reason is we are not enabled discovery client functionality in the order service. That's why those instances you can't see with the Eureka server. See here, still user microservice only. Okay, let's make quickly same steps repeated for every microservice. So let's go with the add status point of view from here. Spring add status. So what is that you have to select now? An Eureka discovery client. So the moment you add it, see here, what are the information being added in this case is this is your old pom.file file and this is the new pom.file file. These are the changes adding. So this property is getting added as well as this dependency is added. And if you observe here some, okay, one more dependency point, Spring Cloud point of view, this section is also getting added. So that's why what you can do is, so you can choose this is the approach. Just select the pom.xml file so that automatically right hand side also you can see now the latest changes, Spring Cloud version and that what is this Netflix Eureka client, and you can see that latest dependency management point of view Spring Cloud also you can see that. So just select only pom.xml, don't select any other things, then your project will be destroyed. Okay, finish it. So that means, okay, I can say like if you are doing for the first time, you have to add this one also. In the build level dependency management, you have to add this one also as an individual point of view. Total 3 things you have to add. But anyway, you can choose from here. It's just one time work point of view. Okay, now next, go to the main method. So yes, here enable discovery client as well as go to the properties file and give service register URL also, like similar to user microservice what you given. I given in the order microservice. Save it. Same thing, repeat for the payment application also. Okay, go to payment application, payment microservice, nothing but Spring add status. So in the existing project, we are adding this status. And then what is that? Eureka discovery client. Next, just select only pom.xml file and click on finish. So second step is, or first step is completed. Then again go to the main method and here at the rate enable discovery client, fine, and then go back to the properties file again and just give the service registry URL. Like that, the number of microservices you have in every microservice level, you have to add these dependencies as well as you have to add all these annotations and this URL. So dependency, annotation, URL. These 3 things you have to add every microservice level. Now let's start payment service also. See, order microservice running on the 2 instances, payment running on the 1 instance. So I can increase, I can decrease, right? Now go and verify in the service registry portal. What is this, guys? This time you can see payment service also running on 8003. So that means we enable payment service also as a discovery client and we given the service registry so that all these payment service microservices, okay, how many instances running? 8003 port number, right? See, only one. That's why only one. So let's see order is getting registered or not. So see order microservice also got registered here. So if you are starting again user microservices, total 3 instances. I mean, you can start individually also. So now see here, every microservice, each and every instance got registered with Eureka server or service registry applications. Instances currently registered with Eureka. So this is the step. This is the thing. This is how we are going to make sure our microservices as a discovery clients are okay, service discovery clients, so that all microservices are got registered with service registry application. So now it's all about dynamic routing to all these instances point of view what we have to do. So now, okay. So with this, what we done, service registry and discovery point of view, we completed these things. So that means what we have done so far right now is we completed service registrations with the registry application. So that means now all 40 microservices or 50 microservices, every microservice information you are centralized at one place. How many instances it is running, on what port numbers it is running, on what host, on which host names it is running, that in that respective microservices. Every information you captured it in a single centralized location called as service registry application or Eureka server application level. Now, okay, now the point here it is, now I'm sending, assume in this case, okay, let's take this one also. So this is your Eureka server point of view, right? Okay, so now what is my next point here it is? So whenever I sent a request from the client application, assume some request coming from client application for slash user slash sign up. Okay, this is the request actually should go to which microservice? User hyphen service point of view. So user microservice level, this request should go. But in this case, user microservice, okay, assume gateway is there. Now, in this case, we will involve the gateway. Now the request reached to the gateway application. In the gateway application level, we hard coded the routing information for user microservice point of view with port number called as 8001 only. So then what will happen right now? The request always goes to the gateway only. Now, as per our discussion, what I said, once we configured gateway also as a discovery client, so we have to make sure this is also as a discovery client. So once we made gateway also as a discovery client, so once we made a discovery client, then it will go to the service registry application and it will, okay, so few more small configurations we have to do that. If you are not made gateway as a discovery client, then directly it will look for, okay, based on the routing configuration, what we given, if you go to this gateway application, based on the routing information, what you given, simply the request always goes to 8001 only. So see here now, if you go to the gateway application of user sign up, create user, yeah, get user gateway, whatever it is. See, this is the gateway URL, right? Now the request will go always to 8001 instance only. So if you want, I can show you that 8001 instance user application, right? So let me open that console. Third instance, yeah, this is the one. This is the application you started on 8001, right? Let's see here now what will happen. I'm sending via gateway, right? So this is our old data. Sorry, you are not started gateway application. Okay, let's start the gateway also. Okay, so we started gateway also, right? So that means we started gateway, we started registry and everything. But only thing is, as of now, we did not make gateway as a discovery client. We have to do this one also. If you are not doing, what will happen? Then service gateway application will look for directly microservice information. So it will look directly for the microservices. So it will directly look for user service based on our routing configuration. That too, what is the routing configuration we given? 8001. So total, even though we have 3 instances started, it will always select only 8001. It will always select only 8001 instance. So that is what I'm trying to show you right now. So see here. Yeah, the request went, you got the response. And observe the request. What you got? API gateway. So it went to API gateway. From API gateway to where it came is user service application. See here, it got here, right? So now let's send one more time. I'm sending, keep on sending the request. I sent almost 8, 9, 10 requests. But if you observe here, all the requests are always coming to 8001. Why? Because we are hard coded here. We given information in gateway application as route always 8001 port only. So we are hard coded. Assume now I stopped 8001 instance. 8001 instance, I stopped it. Yeah, it's up to my choice. I can stop any instances, right? But I should not see the failures of API calls now. Now see what will happen. Gateway application looking for 8001, but there is no 8001. So that's why you got this error. But at the same time, okay, instance is missing. Okay, instance is missing of user microservice. But it doesn't mean like all instances are got stopped. No, already other instances are there. That means your microservice overall point of view up and running. But only thing is one of the instance got stopped it. So that means how to utilize these instances also dynamically every time, irrespective of port numbers, what I stopped, what I started. So that's the reason what we have to do here. It is what you have to do, guys, to achieve the dynamic routing, right? So this is what called as dynamic routing. To enable to get the dynamic routing, what you have to do in this case is, the point is, enable gateway application also as discovery client. So in this case, gateway application also registering with the service registry application. So now gateway application is also made a contract or sharing all the information with service registry application. So let's do this thing, same thing for the gateway application also. So what you have to do, repeat same 3 steps. For that, what you have to do is, first thing is add dependency of Eureka client. Same 3 steps, above 3 steps, Eureka client. So we are making gateway also as a Eureka client application. And then just same second annotation, second point of view, add annotation at the rate enable discovery client. And the third one is add service registry URL. Okay, let's make quickly these changes again. So where you are doing this time, gateway level. So go to gateway application, gateway, and select add status, and then enable discovery client. Next, select the pom.xml. So automatically the dependency will come now. And see here, updating mav and refreshing, all things are happening. Now, what is the next step? Add the annotation. Go to main method and add annotation called as enable discovery client annotation. And the third one is adding the URL. So same URL, just add one more time. So where it is Amazon gateway level, what you are doing, I'm adding the service registry URL. So you can add anywhere else. There is no problem. So I added service registry URL also. So let's restart our gateway application once again. So I'm restarting my API gateway application once again because I made a lot of changes, right? Now see here what will happen. Go to registry application. Okay, so let's go and access our service registry once again. Why it has to display here gateway also. So what was the issue here? It is whenever we are creating Spring Cloud API gateway, so we have two options we found there, right? So for example, if you see here, Spring Starter project, and whenever we selected gateway application, so whenever we are selecting the gateway application, so if you see here Spring Cloud routing, and here you can found two kinds of gateway. So one is this one is reactive gateway. So this gateway is just like traditional point of view. That means it's just following internally the regular servlet and okay, so MVC programming point of view. But this is the reactive gateway. So that means it's just representing the reactive programming. And nowadays the reactive programming is having more importance and reactive is more powerful and performance going to give when comparing with the traditional one. So whenever we created gateway, we created by using this one. So for that, we have some kind of separate configuration to achieve all integration, gateway integration with API gateway, all these things and all. But my suggestion here it is, let's go with reactive gateway. Whenever we created gateway application, just choose the gateway, reactive gateway. Nowadays, this is the one default one we can consider and we can implement reactive gateway so that just create gateway application by taking reactive gateway. And then, so the moment you take in gateway application, reactive gateway, so with this also we can create, guys. So just go back to your gateway application and just what you have to do is you have to create gateway application with this starter dependency instead of this regular gateway. Okay, traditional gateway point of view. So once you are done that, what is the change you will see? Or if you want to modify from our previous example, so what you have to do here it is. So if you observe here, hyphen MVC is there, right? Gateway hyphen MVC. So this is the traditional one. But if you are going with that, okay, the reactive gateway point of view, just remove this MVC. Then this is acting as then this is behaving as a reactive gateway application. So this is the one change you have to do in our existing gateway application, what we discussed in our previous session. Okay, so just remove hyphen MVC, then it is acting as a reactive gateway application. And along with that, what you have to do is, so whenever you remove that hyphen MVC, please make sure. So this is the routing we did based on the MVC gateway point of view. So if whenever we remove, we created gateway via reactive, right? So let's remove this MVC so that now this routing is happening. This routing is going to happen completely based on the reactive gateway implementation point of view. So just that means don't use this .mvc extension as part of this routing. So just these two changes you have to do in your existing gateway application. Now, if you want to go with MVC only, then this configuration is good, and whatever you kept MVC, right? So based on that, again, in the service registry point of view, you have to do a lot of other extra configurations, and we are facing some challenges, right? So instead of that, just go with the reactive gateway. So for that, what you have to do is in the existing application, just remove -MVC in case if it is MVC gateway. Okay, then it will become reactive gateway application, as well as when we made the configuration, right? So we made via MVC earlier and just remove that .MVC so that this routing is now compatible to the reactive gateway point of. This is the only two things we have to do in our gateway application level, as we discussed in our previous session point of view. Okay, so once you are done that, now let's see what's happening with respect to API gateway integration with the service registry application, right? So we want to achieve dynamic routing based on our multiple instances of a microservice. Whenever we scaled up or scaling down the instances, the routing should happen always dynamically instead of depending on the hard coded routing like that. So, right. So let's see here now what is going to happen. Yes, these steps are common again with respect to gateway application. So what we did, first thing is we added Eureka discovery client, okay, in the gateway application. As well as second, what we did, we added an annotation enable discovery client again on the API gateway application level, right? So these two steps we have to do, add dependency and then annotation. And as well as what we have to do, we have to add service registry URL also. So like similar to all other microservices, what we did, we have to add service registry URL, right? So we made this URL also added in our session right now, right? So now let's see, whenever you started gateway application, is it getting registered with service registry application or not, along with all microservices? So let me start all microservices along with registry and as well as API gateway also. So localhost colon 8761 and slash registry. So if you see here, slowly your services are getting registered, right? Still API gateway is having same issue. Okay, I think we given wrong service registry URL. The reason is we have just registry slash Eureka, right? Yeah. We have context path. Same thing we have to give here also. Slash registry slash Eureka. Yeah. So same URL, just what we did in our previous microservices point of view, right? So slash Eureka is always an endpoint when you are configuring inside the application properties, guys. But when you're accessing the portal, you don't need to go slash Eureka. Okay, so now gateway is got started. Let's see, is it registered or not? Yeah, see here now. Now API gateway application is registered with the service registry application also. So that means all our microservices as well as gateway application is also registered with service registry application. So this is the first step we have to achieve the dynamic routing across microservices and their instances. So that means now what happened, guys, in this case is API gateway information is also available along with the service registry application. Okay, so it's a service registry, and now service registry is having which information? It is having API gateway information also. API gateway information also it is having. How many instances are there? All these things. And as well as user order payment. So user point of view, total 3 instances I am running. One is 8001, 8010, right? And 8011, something like that. We are running total 3 instances. Right now, 3 are activated. And similarly, order point of view also, we are taking 8002 and then 8020, something like that we have created, I think, 8021, whatever it is. Similarly, payment also. So if you have more instances. Now this is service register. So this is what we achieved right now with all our configuration. So now let's see the dynamic routing. So that means what is the meaning of dynamic routing? So here you have gateway application, the real gateway application. So this is the real API gateway application. This is just like information. What is the on which port number gateway is running, all these things and now actually the request always comes from the client application. The request always comes from the client application. So then the request came for slash user, okay, something like slash sign up or whatever it is. So this is the request came now. Localhost and localhost colon 8888 API gateway URL is something like that, right? So we want to make sure calling an API of user sign up. So generally what happened earlier, whenever you sent a call to gateway application, so based on the routing information, what you configured, it always went to 8001. So 100% is always, your request is always going to the this instance only, but not these two instances. So that means dynamically the routing is not happening all other instances point of view. It's not happening. So let's see whether it is right or wrong now. So now see here, we started all user services instances and everything, right? So let's go to the this one 8001. So this is what we configured in the gateway application as of now, right? So in the see here, this is what 8001. So let's go to the console of user service application. So this is the console of user service application, right? Let's clear this console. And now let's send the request with respect to microservices point of view and gateway point of view. I'm sending the request. So which microservice I'm sending means slash user create slash sign in, something like that, right? So see here, the request is executed. That means the request went to via gateway to. So this is the URL we sent, right? Yeah, this is the URL we sent. Now what happened, guys, in this case, even if I'm sending same request 100% every time, it will reach to 8001 only. It's not reaching 8002 and sorry 8000 something, whatever the other port numbers, 8010, 8011 point of view, these instances are not utilized. That means load balancing is not happening, and at the same time requests are not forwarded to here. So for that, what you have to do, again you have to add those microservices instances configuration also here. Okay, so that's okay, we can do that one or two, but tomorrow we don't know which port numbers we will utilize all the time, and as well as which instances we are going to bring down across all instances, we are not sure, right? For example, see here, now if I am starting the 8001 instance, what I did, I stopped 8001 instance of user microservice. If we observe here, it is stopped. So only two instances available on 8010 and 8011. So that means in this case, user microservice is up and running, guys. Only thing is, out of three instances, only one instance is down. It's okay, but overall application is up and running. But in this case, based on the existing configuration, what's happening? See here, you are getting internal server error. So that means you can't, that application is down, right? So that's why you are getting this error. So these kind of challenges we are going to get if you are not achieving the dynamic routing across all the instances of a microservice. So how to achieve this in this case? Okay, so what you have to do in this case is, see, even you don't need to do this configuration also. Why I have to do all this configuration? I don't want to do all this configuration. So that means tomorrow user microservice running on 10 instances, okay, automatically all those 10 instances should be utilized equally with respect to load balancing point of view, all 10 instances. And even if I stopped some of the instances, then also the existing instances should be utilized equally. So that means I don't want to hard code. I don't want to say like only this port number has to be utilized always like that. So that means I can remove this configuration also. So now what we are trying to do, dynamically, internally identifying respective instances, and as well as achieving the routing across all instances, dynamic routing with respect to load balancing also. For that, what you have to do, so that means now in this case what will happen, request comes to the gateway. Now gateway application will contact the service registry application, like, okay, hey gateway, hey service registry, I got request for so and so. Okay, for that we have to do some other thing also, so I'll come back to that. So what we are going to do here, it is we are going to send microservice ID also. So that means user hyphen service, like that. We are going to pass microservice ID along with this URL. So the moment whenever you send, what gateway application will do is it will take this ID and it will ask the service registry. So service registry gateway application got this information, right? Now it is asking the service registry, hey gateway, hey registry, I got a request for user service microservice, user microservice. Do you have instances registered for that or not? Then service registry will say like, yes, we have total. So in this case, we have total 3. instances 8001, 8010, 8011 like that. As well as what service register is doing, guys, in this case, it's saying like it is applying the load balancing algorithm. So LB means load balancing. So now service register itself applying some algorithm internally and finding out of 8001 and 8010 instance as well as 8011 instance of these three instances of user microservice, it is just calculating the threshold, okay, traffic, I mean incoming traffic pointer. That means which is having less load. It is identifying the less load instance. That is what calling as load balancing. So it is just identifying the less load instance. Identifying. So then, okay, it identified as 8010 is the less load instance. Then what service registry is saying is, hey, okay, gateway, please forward this request to respective instance of 8010 of user microservice. So that means what happening now? This 8010. So in this case, what's happening? Now the request reaching to the 8010 instance. Now again, one more request came for the same user microservice, maybe sign in operation or whatever it is, maybe sign up, whatever it is. One more request. Then again, same load balancing will be applied by service registry. So now what gateway is asking? Gateway is contacting the service registry like, okay, I got a request for user microservice. Do we have instances or not? Now again, the service registry is saying, yes, total 3 instances. We have 10, 1, 11, 8001 like that. And it is identifying the less instance. And this time it found 8011 is having less load. Let's take the request like that. Now similarly, one more request came. Then it identified 8001 as a less load. So the request is shared to the 8001. Now, okay, this is the scenario, right? Now, some reason I stopped 8001 instance. So now that means what are the active instances available right now? In the service registry point of view, what are the active instances right now? Earlier 3, I stopped 8001. So that means right now 8010 as well as 8011 instances are there. Now again, same request came to the gateway with respect to user microservice point of view. Now gateway is asking service registry, hey, I got request for user service. Do we have instances or not? First of all, do we have instances or not? Now it is saying like, yes, we have 2 instances. So service registry. And as well as service registry, just identifying the load balancing point of view, internal it is calculating the less load instance. So it's identifying the less load instance and saying like, okay, 8011 is having less load. Let's forward, let's route, I can say like route the request to this instance. Route the request to this instance. Now one more request came. So then again it will calculate load balancing point of it found 8010 is the having less load. Like that, the load is equally distributed all the instances and along whatever the instances available, those are all things dynamically utilized. See here now, we removed entire hard coding configuration. I did not say like 8001, 8010. Now tomorrow, if I started my microservice of user service on 9001 also, it will work. Even if I started at 9010, 9011 port numbers also, it will work. Why? Because we made everything dynamic communication in between gateway application and service registry. We are making a dynamic communication. So every time what gateway is doing, gateway is not okay, depending on its hard coded information. We removed that. Now, no information, no configuration. We are not given any information. This time, what we are telling to the gateway, do contact the service registry. Service registry application will give you the live instances of each microservice. Now, okay, one more request came, something like localhost colon slash order hyphen service. Okay, I will tell you how to configure this. I mean, we will see example practically also. Something like create order or whatever it is. Now, in this case, what again it is doing gateway application. This time, no configuration. You don't have any configuration, routing configuration. We don't have any routing configuration, right? So what it is doing dynamically, it's contacting the service registry and asking, hey, service registry, I got request for order microservice. So order service. Then what it is asking service registries, do you have instances for order service or not? Yes, we have for order service, right? So then it is saying like, yes, total 3 instances we have. Let me identify one of the instance which is having less load. Like that, it will identify one of the instance, and then the request will be routed to respective instance. Now one more request came. Okay. So load balancing point of view, all 3 instances are utilized equally. Now if you stop at one instance, yes, then only the existing two will be utilized. Like that, you are achieving the dynamic routing. So that means in this case, what API gateway is doing is it's not utilizing its own configuration. Even we removed right now. So that means there is no configuration information. Instead of that, what we are saying is we are asking to the gateway, go and contact the service registry, and based on the service registry information, route the request. So that means now you achieve, we enable API gateway as well as service registry integration, so that API gateway always dynamically contacting the service registry for dynamic instances. The instances which are running all the time, which are went down, is, and it doesn't matter for us. At least one instance is there, your application will run. So you are removed the completely hard coding from the API gateway. See here guys, I removed completely from the API gateway. Now I don't have any routing configuration like earlier. So earlier we have this one, right? Predicates, all these things. Now I'm removing all those things. Okay. So that means the moment you removed all these things, now let's send the request once again. Let me restart gateway application once again. I saved it. So by default, it is working or not. Let's see here. Okay, I'm starting 8001 and everything. See, I started gateway, registry, and all microservices and every instances also. Now I'm sending request to 8000. See, it is saying like no instance found for the user microservice. Why? Because we removed the configuration. But we have to do some small extra thing now going on to achieve this dynamic routing. So what it is, let's see here it is. So that means you added this service registry URL here. Yeah, these are the 3 steps you are doing. Now with respect to dynamic routing point of view, what are the steps we have to do here it is. First thing is we have to add a property in gateway application. In a gateway application, something like discovery is enabled. Like that, we have one property. What is that property is? So here only you have to add that property. So in the gateway application, you have to add one extra property to achieve this. Right now we discussed it, right? Last 10 minutes. This dynamic routing with respect to, so gateway by default. So in this case, gateway application by default not contacting the service registry for all available instances of a user microservice. So to achieve this behavior, what we discussed from last 10 minutes, dynamic routing point of view, these are all the steps you have to follow. First thing is add a property in gateway application, and the property name is something like spring dot cloud discovery, spring dot cloud dot, yeah, gateway discovery locator enabled. Okay. So if you see here, flag that enables discovery client, flag that enables discovery client gateway integration, gateway integration. So I'm just saying like, yes, I'm trying to integrate, okay, discovery locator enabled. So that means gateway is going to locate all the instances of every microservice point of view. Okay, I added this property. So add a property in gateway application. So that means what you're trying to say here it is discovery locator enabled. So it is, so that means in this case, gateway application is having extra privileges, something like it is going to identify all other microservices information point of view. So that is the step number 1 you have to do. Step number two, what we have to do in this case is we have to follow an URL pattern as below to achieve same routing point of view as below. So what is that is? So what you have to do here it is, generally what is the URL we followed for earlier gateway point of view? This is the one, right? Let's take the gateway URL. So in general, before we use it, this is our gateway URL, right? So localhost, gateway port number, as well as user and create. So user create is the API actually in this case, right? Similarly, what I can take this one also, right? This is also gateway URL only. Now, if you take an order point of view also, the previous one what we use. So this is also gateway URL with respect to what we did manual routing point of view. So that means this is all about manual routing, what we added in the configuration file. Routes we configured, right? So that is what this is all about happen. But right now we are not doing manual routing. Go to this port number like that. We are achieving dynamic routing with respect to service with the help of service registry, right? So that's the reason what we have to do in this case is, so with respect to dynamic routing point of view, after, so what is the syntax point of view I'll give you. So what is the syntax you have to follow here? It is gateway host name colon port number. So gateway application port number, nothing but, okay. Slash, here you have to follow service ID. What is that, guys? Service ID. So service ID means your microservice ID, and then slash the real API, and then slash the actual endpoint. I can call it as endpoint. So what you have to do in this case is you have to attach always service ID. After the port number, we have to attach service ID. So that means if I taken this one, so the URL will become what? See, this is the actual endpoint. If you go to the user microservice, where is the user microservice? Go to the controller class. Slash user is the context path, okay? And then slash create is the endpoint. So that means this is the real endpoint of user microservice. But before that, what I said here, you have to attach the service ID. So we have to attach the service ID. What is the service ID? User, service, payment services. These are all service IDs. Microservice names, microservice IDs. That's what I said. Going on, these properties will play more important role. Now, this is what our service ID. This is what our service ID. But one small rule here it is, okay, by default, okay, rule, what is the rule here it is? By default, service registry always considers every service ID in uppercase only. So that means that if you observe here, see in the real microservice configuration file level, we given in the lower case only. Usually we have to give in the lower case only. But if you observe one more point, in the service registry level, whenever your microservices got registered, every time it is registered with what, guys? It is always registered with uppercase letters. So everything is converted to uppercase. So that means in this case, the service ID you have to pass always the way uppercase, okay, the way the service ID registered with service registry application, same thing you have to use here. So that means now I have to use like this. This is what the syntax you have to follow. So service ID, that means microservice name, and followed by the endpoint. Now similarly, if you want to send a request to order microservice point of view, what you have to do, guys? So in this case, slash here, you have to attach the service ID. What is that service ID? Order service. And it has to be in the uppercase letters only. So if you given the lowercase, what will happen? We will see that. And similarly, if in case payment point of view also, what, for example, if you take in previous payment options, right? So this is also payment one, right? So in case here, what will happen? Payment microservice ID. What is the payment microservice ID? This is the one. Simple thing is, only thing is everything in the uppercase. So like this, you have to frame the URLs. Now what will happen, guys? This is what I said. So this is how the URLs now we are going to share with the client team. Now we will ask the client team, we will always share with them these URLs. So front end point of view or whatever it is, whenever they want to create user account, sign up or whatever it is, every time we will give this URL formats to them. So go back here to the client point of view. Yeah. So these are the URLs, right? So these are the URLs we are passing. So now that's what I said. This is the service ID. This is the service ID. What gateway application will do whenever this request comes to the gateway, what gateway will do is it will take this service ID and it will ask the service registry, hey, service registry, do we have instances for this or not? Then it is identifying, and as well as what service registry is doing, guys, it is applying the load balancing also. So that means the requests are distributed equally to each and every instance. All three instances will share all incoming requests. Like that, all microservices will act. Like that, order service, payment service, notification service, like the number of 40, 50 microservices you are having, and those, their respective instances, everything is automatically routed, as well as every instance is automatically, okay, with respect to load balancing point of view also, every instance is utilized equally. So whether it will happen or not, let's see now. So what I will do, let's take this URL first. See this time, see, without that service ID, if I'm sending the get user info or something like, right? So send it. What it is saying? No. Why? Because this time we removed the routing information from the gateway application. If you go to the gateway application, what we did, we removed entire routing, because this time we want to achieve everything dynamic point of view. We don't want to hard code the details here. Tomorrow, if you added one more microservice also, delivery microservice, return microservice, something like that, I don't want to do anything. Everything let's make it automatic point of view. So that's the reason it is not working. But instead of that, what I said right now, let's take this. So gateway as well as service registry URL. So what I said here, oh sorry, 88888 gateway URL slash user hyphen service. And this is the real endpoint. This is the actual endpoint. Okay, user microservice. This is the context to path as well as respective endpoint, path parameter or whatever it is. But here what we did, guys, when comparing with this one and this one. So when comparing with this one and this one, what happened? You attached service ID, microservice ID. So that means you are saying like this request should go to user microservice. And you are sending via gateway only. See, this is the gateway URL. 8888 means which port number we given gateway. If you observe here, gateway. Now gateway will contact to the service register. Once I'm sending the request from the client, what will happen? The request, see, you got the response now. And observe, that means what will happen? Same story. So the request went. So then user microservice point of view, it is asking the service registry, and service registry is saying like, okay, gateway, we have total 3, 8001 and 8010 and 8011. Let me find out which is having less load. Like that, it is finding as well as it is sharing the load. See here, if you observe here, I don't think let me go to the user microservice. At least we will add some logs. I think we already have it. Email ID, get user info. Yeah, anyway, it will print Hibernate SQL query, right? See, if you observe here, what is this microservice, guys? User service application. That means 8001 port. So that means what I can say this time, you can't see logs printed means the request not reached to 8001. It went to some other port number. Let me find out which one I will show you. So 8000 user second instance. See here, this is where. So second instance means this is the one. 8010. So that means the request went to which port number now? Out of so total user microservice point of view, we have 8001 and 8010 as well as 8011. So this time the request came here. The request reached here, right? So 8011. If you observe, okay, sorry, second instance means 8010. So here it came to here. First request. Now let me send one more request. See, I'm blindly sending requests. Second time, third time, fourth time, fifth time, sixth time, seventh time, eighth time, ninth time, 10th time. So 10 times I send the request. That means total 10 incoming requests to our microservices application. Now go and observe how many instances. See here, your second instance got hit total 3 times. But I sent actually 10 times, right? That's what load balancing. Now go and observe. This is second instance, right? Let's observe the first instance or third instance. Okay, let's take third and see 3. So that means total, what happened? Second instance level, you got 3 instances, 3 requests, and again 3 more in the second one. And let's go to the 8001 also. Where it is? Yeah, this one. See here also 3 times. So that means what's happening, guys? 333. That means every time the requests are dynamically routing to all instances, and as well as load balancing also you are achieving. We are achieving. So what are the concepts we achieved here? It is we are seeing like dynamic routing plus load balancing. This is the biggest advantage you are getting in this case. See, this kind of configurations we will do in the microservices, guys. That's what I said. Microservices is nothing but a architecture. It's all about the way you are okay constructing your microservices, managing or dealing with microservices, management communication point of view. You will have all microservices concepts. So it's not like a programming concept. You have to write 1,000 lines of program with respect to microservices. No, microservices is not a programming language, not a tool, not a technology. It's just like an architecture point of view. You have to build all your microservices. See here how much biggest advantage we got right now. So we are utilizing all three dynamically. See now I will stop 8001. Okay, no problem. Until and unless at least one instance is available, your microservice is available only. See, I'm sending the request. Now I'm getting the responses. Let's create the user account also. So this time these things will not work, right? So let's what I will do slash user hyphen service, right? Send the request. See user account created success. Send it, send it, send it, send it, send it. So like that you are getting. Okay, it's all just like load balancing point of view. You are getting it. Multiple requests, right? You are sending keep on, that's what. But what you can observe here, see, this is terminated one. And if you go to the, I sent 5 to 6 times, right? See here, one time, second time, 2 times I sent, but I can see only one time. So that means one request went into one more instance, one more request went into one more instance. The incoming traffic is distributed across all instances. Similarly for all order microservices also. Gateway, right? What you have to do slash here order hyphen service. Send the request. So you got the response. And if you want how many instances we have total 2, right? 8002, 8020. So if you want, you can go and check order service also. Order service. See, this is the one you got on first instance. Now let's send the request again. See here you are not seeing. That means what is the meaning? It went to second instance this time. Let me switch to second instance. See this time it came here. Now if I'm giving any other things also, so the request are always responses coming, but the data, the incoming requests also shared across all instances. Even if I added few more instances, if I started extra instances, or if I stopped some of the instances, never ever your communication of microservices will fail. That means your request will not fail until and unless all instances became 0. Then there is nothing will happen. If every instance is down, then there is no point. At least one instance should be available. See now if I'm sending request with respect to user microservice point of view, what will happen? You will not get server error. You will get server error. Why? All instances are down. Now if I started again, now all 3 instances will be utilized by gateway application, or dynamic routing will happen for all instances. So this is the biggest advantage, and this is the biggest configuration or challenge we achieved in this case. Dynamic routing across all instances, as well as it's not about dynamic routing, it's all about internally load balancing is also happening. Default load balancing. Default load balancing. So this is what called as load balancing. As an interviewer, they'll ask you what is the load balancing and how you are achieving load balancing in your microservices architecture. You can tell them this story. So we integrated API gateway with service registry, and internally service registry is always having default load balancing. So whenever we send request, gateway is making a call to service registry, and internally service registry point of view. Okay, if you go to service registry console also, so it's always making health checks. of every microservice pointer. If you enable the debug logs, then you can see that. You can see all the information, everything. So if you enable the debug logs, log level made as debug, and then you can see a lot of information what's happening internally and all. You can see that. If you want, I can do one time. Is it enabled earlier? Yeah, this is all. So in the gateway, you're already enabled it. And even if you want to, you can enable here also. Gateway, I started once again. I'm restarting all microservices. See, I'm just showing you practically internally what's happening and all. You can understand when you enable this log level to debug level. So what I will do right now is I'll open API gateway. Okay, let's refresh the browser portal also. Now see here, you can see all microservices which are registered, 2 instances, 3 instances, port numbers, and everything you can monitor from here also. So that means as a developer from tomorrow, you can easily understand. Okay, you can see from this page, you can see how many instances are running and which port numbers, how many instances available. All these things you can monitor from here also. That is how it will work. It will help us, this portal. Now let's send the request. Gateway point of view. Okay, you got 200. Okay, right? Now in between, what is the process happened? Understand here. Internally route definition. See routing. That's what we understanding dynamic routing. So what it is seeing, guys, see here, see here. Pattern, Amazon API gateway, star star. Yeah, that's what we did. And then payment service, order service, user service. We made for user service right now, right? Star star. Then internally, it's just remaining or whatever it is. It's all their logic. Finally, what happened? Internally, it found respective instance. Even if you go to the gateway point of view, see gateway point of view also, you can identify what happened. Filter user service remaining, all these things, and as well as service registry. Yeah, service registry point of view, see here. Gateway, API gateway 8888, that's okay. See internally, we sent request for a user service point of view. It is taking help of all these things. So it is always, even you can observe one more point here. Every time service registry, all the time for every 5 seconds or 10 seconds, we are not sure about the time, but it is making always a health check call. Like user service, all instances are up and running or are all up and running or not. Order is up and running or not. Like that, every time it is making internally, it will be called as heartbeat. It is checking service registry always checking heartbeat of all microservices instances. Health check or heartbeat, whatever you can say. So whenever it found something like one of the instance got stopped, then internally it will remove that information from the service registry. Okay, so this is okay until this. So that means we achieved finally dynamic routing along with load balancing, by default load balancing, by integrating API gateway application with the service registry. But the point here it looks bit weird, right? So what is the weird? Sending service IDs in the uppercase. If you given in the lowercase, what will happen? See here. Same microservice only. I'm not doing anything, just sending data into lowercase. Because generally URLs, whenever you observe every time lowercase only. Okay, API gateway, the rule what I mentioned, it will always accepts everything in the uppercase only. Like what you see in this portal, like uppercase, yes, it will accept internally by default uppercase only. But if I am sending the lowercase, what will happen? See here, you are saying not found. What is the meaning of not found? It is not found this microservice ID. So that means in case if you are forwarding the lowercase, so that means the point here it is, in case if we are passing service ID, nothing but microservice ID in lowercase, then your API will fail. API call will fail. So that means what you got 404 not found. But if you made again uppercase, same thing, you are getting successful response. But it's not a good way, right? It's giving in the uppercase format. Yes. In this case, Spring Framework again given one more property to enable lowercase service IDs also. So that means what in this case it is doing is, if you want service IDs in lowercase format as part of URL, we have to enable first. By default, uppercase only, we have to enable by adding below property in gateway application. So where you have to add again, here it is gateway application. So go to the gateway application, open this property. Yeah, come back here, spring dot cloud dot gateway dot discovery dot. Yeah, if you see here, lowercase service ID, Boolean value. So by default, it will be false. So we have to enable now. We have to add it to. So that means you are enabling to the lowercase. So let's restart your gateway application one more time because we made change, right? Safer side, I am doing that. Yeah, now let's go back here. Now what is the point you have to understand here? It is send the request. Now see here, when you are sending uppercase, it's not working now. This time what happening, guys? The moment you added that property, what is that property? Let me take that property also. Yeah, this is the property. So once you made this time what you got, uppercase is not working. Uppercase service ID not works. So that means you can deal at a time either uppercase or lowercase, but generally standards are always lowercase, right? So that's why you can now same URL, if I am passing again with respect to lowercase point of view, user hyphen service. Now it will work. Send the request. Now what happened? User created successfully. So that means 200. Okay. So what you understood here it is, by default service IDs are always accepted as uppercase only. If you are passing lowercase, you will get 404 not found. In case if you want to pass lowercase service IDs, then we have to enable it by adding this property in the gateway application. And once you enable this property, so next time onwards, you can send only in the lowercase but not in the uppercase. So that means you can maintain either uppercase or lowercase service IDs as part of this URL formation. So better thing is always enable in the lowercase because this is always a standard. It looks good, right? So when comparing with the previous one. So that means make everything as a lowercase point of view. Now what will happen? All your URLs will become lowercase point. Now if you go to the order microservice point of view also, yeah, here also user hyphen service, you got the response. Similarly, 8888 order hyphen service, you got the response. So this time onwards lowercase. But here still it is showing uppercase only. But that means in this case gateway level, gateway URL level, we are passing with the lowercase format to the gateway. But internally again it will check. Internally it will make sure converting to uppercase and checking with the service registry. That's a all internal story. So that means user service, order service, like that all service IDs you have to pass in the lowercase. Payment hyphen service. So this is how finally we are completely done with service registry and service discovery point of view. So what we achieved so far, guys, in this case, we created service registry application as well as we made all our microservices as a discoverable clients so that all our microservices always registered with service registry in a single place and a centralized location point of view. So that now by using this centralized information, we made API gateway also communication point of view with respect to API gateway is always handling incoming request. As well as what API gateway is doing with this information, it is forwarding the request to respective instances every time. And in this case, service registry is helping us with default load balancing also. Yeah, this is what load balancer. So internally, it's having default load balancing also so that all requests are routing to respective instances and those requests are always executed from those instances and responses generated from those instances and coming back to the client again. So this is how it is helping us. So with this, we are completely done with service registry and service discovery. So what we have to do for service registry, what you have to do for service discovery point of view, we understood. So service registry is a separate application and gateway is a separate application as part of our microservices architecture. So we are done with what two things: how to create API gateway application and how to create the service registry application. But service discovery point of view, generally you will make only your existing applications itself as a discovery clients. So those all information shared here, and internally API gateway will utilize that information, and API gateway will make a call to respective instances of every microservice like that, which are coming from the client applications, mobile apps, browser applications, IoT applications, whatever it is. So this is completely Spring Boot backend application. And we will see in the next session, we will understand what is the config server in the next session. So far, whatever the concepts we completed as part of microservices along with our Spring Boot, all these topics are already available in the material. Okay, so if you see here, I just discussed all the details about what is the microservices and what are the differences between microservices and monolithic application. And I included all the concepts, whatever it is like API gateway creation, step-by-step point of view, with respect to all flow diagrams and architecture diagrams point of view. And I included all these steps with respect to implementation of gateway application. Yeah, as well as you can find out all these steps, what we are discussing as part of our regular sessions, everything is documented here. So if you see here, so how to do the routing and sample routing point of view with respect to gateway application. Similarly, I given all the details about service registry and how to create service registry application. Even in today's topic, completed the discovery client side. So that is also we discussed with respect to API gateway integration with Eureka server. So what are the steps you have to follow while you are integrating API gateway with service registry application, and what is the syntax you have to follow while you are making call for dynamic routing point of view. And with respect to lowercase point of view also, what are the properties we have to add. Everything whatever we discussed so far, each and every point and each and every step is documented as part of this material, and this material is going contains all other upcoming topics also. So if you want to buy this material, so you can find out from this website called as courses.dilipit.com. So from here you can purchase, and this is having entire Spring Boot as well as microservices along with regular frequently asked interview questions topic wise, as well as I consolidated all interview questions at last in the document. And this is all about, you can buy one time, you can access lifetime. So this is one time purchase, and but as well as you can access for lifetime, and this material will be updated with all upcoming updates of existing microservices architecture as well as Spring Boot, and including the upcoming new interview questions also I'm going to add as part of this material.